90% of Canada is effectively empty. Not because it's unlivable everywhere, but because one massive geographic force quietly pushes almost all life to the edge of the country. Right there in the middle of Canada sits something that looks like a giant bite taken out of the map. A vast freezing inland sea so powerful it reshapes climate, economy, and even where entire populations are allowed to exist. This is the Hudson Bay, and it is the reason Canada has what can only be described as a massive geographic dead zone that stretches across thousands of kilometers of near-empty land. And if you think this is just about cold weather or empty land, you're missing the real conflict. Because this isn't just a natural phenomenon sitting quietly on a map. It's a system that connects ice, geology, colonial history, and modern energy power in a way that still silently controls one of the largest countries on Earth. And here's the real promise. By the end of this story, you'll understand how a single ancient ice scar became a climate engine, a population barrier, and a hidden power source that still defines global energy flows today, in ways most people living in Canada never really think about. Now, to understand why Canada's dead zone exists at all, you have to zoom out and see the scale of what we're dealing with. Because nothing about this feature behaves normally at any level, and the deeper you go, the more unnatural it starts to feel. The Hudson Bay is not a small inland lake or some frozen regional sea. It's enormous. Located in northeastern Canada, it touches Manitoba, Ontario, Quebec, and the vast northern territories, wrapping around a huge portion of the country's center like a missing piece of land. It connects to the Atlantic Ocean through the Hudson Strait, and indirectly links toward the Arctic through complex northern channels that feel more like broken waterways than stable routes. In total, it covers more than 1 million square kilometers. That makes it one of the largest inland seas on Earth, so large that it almost stops feeling like a body of water and starts feeling like a continent-level feature. You could fit entire countries inside it and still have room left over. It's so massive that from space it doesn't just look like a lake or bay. It looks like the continent has been carved open, as if something massive once punched into the center of North America and never fully healed. But the strangest part is not its size. It's what happens when you go beneath the surface and realize the geometry of this place doesn't match any normal ocean system, not even close. Because unlike true oceans, which plunge into deep abyssal trenches and massive underwater mountain ranges, shaped over hundreds of millions of years, the Hudson Bay is shockingly shallow. On average, it's only about 100 meters deep. In ocean terms, that's barely anything. It is not a deep basin carved into the planet. It's more like a wide sunken platform sitting on top of the continent itself, a kind of flooded geological memory rather than a true ocean basin. Geologists call this an epicontinental sea, meaning the ocean didn't carve a hole into the Earth here. Instead, the continent itself dips slightly and water simply pools into the low point. That detail is crucial because it means the Hudson Bay is not separate from Canada. It is literally resting on top of it, shaped by forces that are still slowly adjusting even today. So, the first major clue to Canada's dead zone is this. The Hudson Bay is not really an ocean feature. It is a flooded section of the continent, held in place by shallow geography and ancient geological pressure that never fully disappeared. And that changes everything about how it behaves, especially when climate enters the system, because shallow water reacts violently to climate shifts. It warms faster, cools faster, and most importantly, in this case, freezes faster and more completely than any deep ocean system ever could. There is no thermal stability, no deep buffer zone, no slow resistance to change. It reacts directly to air temperature like a massive exposed surface. But before we get to the ice, we need to understand another hidden layer of this system that most people never think about when they look at a map of Canada, even though it is constantly shaping what happens here. The Hudson Bay sits at the bottom of one of the largest drainage systems in North America. Rivers from thousands of kilometers inland slowly funnel toward it like veins converging on a single organ. Water from forests, lakes, and distant mountain runoff across central Canada all eventually make their way into this single basin. That means the bay is constantly being fed with fresh water, not just seawater from the ocean. And that freshwater inflow creates a chemical imbalance that quietly reshapes everything about the system over time. Unlike the open ocean, which is stabilized by salt, the Hudson Bay becomes diluted over time, especially near the surface. It is not fully fresh, but it is far less salty than normal ocean water. And that difference is more important than it sounds, because salt is what keeps oceans liquid at lower temperatures. It lowers the freezing point and stabilizes large bodies of water against sudden seasonal collapse. So, when winter arrives, the Hudson Bay is already structurally unstable in terms of freezing resistance. It is shallow, it is cold, it is diluted, and it is constantly being pushed toward a phase change every single year. And that is when the transformation begins. As Arctic air masses sweep down across Canada, the temperature drop hits the bay with full force. Ice begins forming rapidly across the surface, spreading outward until the entire system locks up. At peak winter, more than 1 million square kilometers of water becomes solid ice, turning the bay into a temporary extension of the continent itself. At this point, something even more important happens beneath the surface of that transformation. Something that rarely gets mentioned, but is essential to understanding the system. As ice thickens, it begins to insulate the water below it. That insulation traps certain heat exchanges while also locking in freshwater layers, creating a stratified system where different layers behave almost independently. This makes freeze and thaw cycles not just seasonal events, but structural reorganizations of the entire bay. In some regions, wind pushes ice into massive pressure ridges that stack upward like frozen walls. In others, shifting currents crack the surface and refreeze it in chaotic patterns that can extend for hundreds of kilometers. The result is not a smooth sheet of ice, but a constantly rebuilding frozen architecture that changes shape throughout the winter. And in those months, the Hudson Bay stops acting like water entirely. It becomes land, a frozen platform stretching across the center of Canada, temporarily rewriting the map in real time. And this is where the idea of a massive dead zone starts to take physical shape in a very literal sense. Because this frozen surface does not behave passively. It actively reshapes the climate around it in ways that ripple far beyond its edges. Normally, oceans act like thermal buffers. They absorb heat in summer and release it in winter, smoothing temperature extremes and making nearby regions more livable. But the Hudson Bay does the opposite, especially during freeze conditions. Instead of buffering Canada's climate, it amplifies it. When Arctic winds move southward, they do not cross a warming ocean. They cross a frozen plain. Wind travels unbroken over ice, picking up speed and maintaining its extreme cold. The bay becomes a kind of atmospheric conveyor belt, exporting Arctic conditions deep into the continent. It is one of the main reasons central Canada remains so sparsely populated and so difficult to develop at scale, especially outside narrow transportation corridors. But the effect becomes even more dramatic when you zoom out to population geography and look at the country as a whole. Canada is the second largest country in the world by land area, yet nearly all of its population is compressed into a thin southern strip along the border with the United States. In effect, it looks like most of the country is empty, but that emptiness is not random at all. It is structured, almost forced, because north of that strip lies a combination of factors that stack together like layers of resistance. The rocky and ancient terrain of the Canadian Shield, the harsh climate driven by Arctic air masses, the distance from global trade routes, and the central freezing influence of the Hudson Bay itself all overlap. Together, they create a zone where large-scale agriculture, dense urban development, and efficient transportation networks become extremely difficult and expensive to maintain. So the country is squeezed, a vast nation reduced to a narrow band of livable space, stretched along its southern edge like a compressed ribbon. And the Hudson Bay sits right at the center of that compression, acting like a climate engine that reinforces the emptiness around it year after year, generation after generation. But the story does not stop at geography or climate, because this same system that creates a dead zone also created one of the most powerful economic engines in colonial history, and that legacy still echoes in modern infrastructure. To see that, we have to step back into the early 1600s, into a world where maps of North America were still incomplete and imagination filled in the gaps. European powers were searching desperately for a shortcut to Asia, a mythical route called the Northwest Passage. Whoever controlled it would control global trade flows between continents, and the stakes were enormous. In 1610, an English expedition entered icy waters north of Canada and eventually found itself inside a massive inland sea. At first, it seemed like a breakthrough, a vast open water system that might connect to the Pacific or provide a route through the continent. But as winter arrived, the truth revealed itself with brutal clarity. The shallow freshwater froze quickly, trapping the ship in ice. What had looked like opportunity turned into confinement. The crew was forced to survive an Arctic winter in isolation, surrounded by a frozen ocean that refused to release them, cutting them off from any known route home. And when spring finally arrived, the situation collapsed into mutiny, one of the most infamous breakdowns in exploration history, leaving the expedition leader and loyal crew abandoned in the frozen expanse with almost no chance of survival. From a European perspective at the time, the bay became known as dangerous, unstable, and almost hostile to human ambition. A place where navigation itself seemed to fail. But that reputation did not stop exploitation. It only changed the strategy of how people approached it. Because within decades, people realized something crucial. The Hudson Bay was not just a trap, it was also a perfect collection point for an entire continent's resources, and that changed everything about its value. Almost every major river in central Canada flows toward it. That means furs, timber, fish, and inland goods naturally funnel toward its edges over thousands of kilometers of drainage systems. Instead of fighting through hundreds of kilometers of land transport, traders could sail directly into the bay and meet indigenous trading networks at the natural endpoint of the system, where everything already converged. This insight triggered one of the largest corporate land claims in history, when a royal charter granted control over an enormous territory surrounding the bay, effectively turning it into a commercial empire built entirely on geography itself. Trading posts were established at river mouths, acting like control points for continental trade. Over time, this system grew into a corporate structure so powerful that it operated almost like a government, shaping settlement patterns, regulating trade flows, and influencing infrastructure decisions across vast regions of northern North America. And that influence still echoes today in modern Canada, even if most people never notice it directly. But even now, the most important role of the Hudson Bay is not historical. It is physical, economic, and ongoing in ways that are still evolving, because the same rivers that feed into it are now being harnessed for energy. Massive hydroelectric systems across Quebec and Manitoba convert the gravitational flow of water toward the bay into electricity at industrial scale. Entire landscapes have been reshaped to control that flow, turning natural drainage into engineered power systems. This energy powers cities, industries, and is even exported into the United States, meaning the Hudson Bay watershed quietly contributes to a much larger continental energy network that spans borders and economies. At the same time, the geological forces that created the bay are still active. The land that was once crushed under kilometers of ice is still rebounding upward in a process known as isostatic rebound. The Earth's crust is literally rising, slowly reshaping coastlines and altering how water drains into the basin. In some regions, new land appears gradually over time, changing shorelines so slowly that the shift is almost invisible unless measured across decades. So the dead zone is not fixed. It is still evolving even now, beneath what looks like a stable map. And now, a new shift is beginning that could change its role entirely. As global temperatures rise, the frozen period of the Hudson Bay is shortening. Ice forms later, melts earlier, and shipping routes that were once impossible are gradually becoming more accessible for longer periods each year. This introduces a new possibility, a future where the same region that created a frozen dead zone in the center of Canada could become a strategic Arctic-adjacent trade corridor, connecting continents in ways that were previously unthinkable, a barrier slowly transforming into a passage. So, when you step back and look at the Hudson Bay, you realize it is not just a geographic depression or a frozen inland sea. It is a system that builds cold, concentrates population, shapes history, generates energy, and may soon reshape global trade once again as climate conditions shift. And that brings us back to the original question. Why does Canada have a massive dead zone in its center? Because at the heart of the country sits a body of water that refuses to behave like anything else on Earth. It is shallow enough to freeze completely, large enough to control weather systems across an entire continent, connected enough to gather an entire drainage network, and powerful enough to shape both history and modern energy systems at the same time. It does not just sit in Canada, it defines Canada. And the most important part is this: The Hudson Bay is still changing, which means the map, the climate, and even the flow of global power connected to it are still being rewritten in real time, right under the surface of a frozen sea most people barely think about.